Now, I would shortly like to speak about these principles that we need to know about to think about the relative time in geology. What does that mean that we're speaking about relative time? It's just like you imagine yourself, your parents, and your grandparents, and just the way you look like. We might say who is older and who is younger, but we're not going to be able to tell exactly the age of the individual person or the difference between the age of you and your parents. We need to do more detailed analysis of blood tests, whatever, how we can, in a way, prove the actual age in years of a person. So here we can just think about what is older, what is younger. And the amazing thing is that just by using these few principles, scientists, maybe like 100 years ago, already pretty well could put together the history of the Earth. We didn't know exactly the age, but we had a good idea about which rocks are young, which are old, how did the planet or bits of the planet develop in time. So, first of all, superposition. Well, you can just remember this word, superposition, and it will mean that below are usually older, and above them, younger materials. What does it mean, or why is this so? If you think about how like the ocean would look like, so this is the sea, and what we have here perhaps on the bottom of the sea, so this is the bottom, the sea floor, is mainly dead animals. So I just put in here a dead like fish. It's completely dead. There's only the skeleton, so the fish bone. And what this will build up, we have lots of these dead animals, is limestone or some kind of carbonate on a long run. And what we will have here is obviously different species, like this snail, dead snail, and its shell. You can have shells as well, yes, mollusks. So these dead animals would usually build up this depositional or sedimentary rock that is the base of the seafloor, and usually first what we have is older and later on new layers of these material will be deposited on the already existing ones. Or if we think of like a volcano or shield volcano would usually look like, we have these layers of like magma coming out. Here's like actually the magma chamber and the volcano, and we will have new layers that are built on the already existing ones. So this is superposition. The newer, younger is on the top, the older is on the bottom. Now this is obviously not always the case, but it's just kind of a principle that we can just think of, because many of the materials, if you think under your feet, if you are in Jiangning, if you dig down in the plain, so obviously you have these kind of depositional sedimentary rocks, it will often be true. That's superposition. Horizontality. Exactly the same as we said, materials usually will be deposited horizontally. So like water. If this is the sea surface, then under the sea, the materials will be in such layering. They will not normally be deposited in an angle. It can happen if this is like a side of a mountain, then here we can have different rocks that build up like a slope, but usually we can say that materials will want to be deposited in a horizontal like 0-degree angle. Again, if we think here of like the sea floor, how it's built up, we have these dead animals, perhaps here we have fish, and when they die, they will go down on the surface of the sea floor and build up this material that is slowly developing, and it will usually be something horizontal. Or if we think of like again a volcano and how a volcano will erupt, often is a help, or here we can just draw this ash cloud. Now the ash material, so this powder, will build up layers maybe hundreds of kilometers away from the actual eruption of the volcano. And so this layer, again, will be horizontal. So originally we can say that rocks are or were in a horizontal position. If we see layers like this, that we can say originally they were horizontal and something happened in time. And then we can just start speaking about more exciting topics, because these are really simple. Cross-cutting. Cross-cutting relationships. It means originally we have some kind of layers. They, we might say, are horizontal. We might say that the bottom or the earlier layers are found on the bottom or deep down below. And what we can, by time, identify that maybe there was a crack over here. So these rocks broke apart, and by time, some kind of other material like magma here filled in this crack that developed. And this cannot be in any other case, any other way, but the first we have layers over here that developed. Then, by time, newer layers developed over here, and the most recent could be originally over here on the top, but actually, currently, we have the emergence of a new material here that is perhaps crystallizing, so like volcanic material squeezes itself through in the cracks of the rock. And in this case, we will say that cross-cutting, it's cutting across existing layers. So that's why this will be younger. In nature, very often we will find this. You might think how or where, but actually rocks will often be formed in this way. You have an original parent rock, and then you will have these joints that fill in the cracks. You can also think of like volcanoes. Volcanoes also will be like this. Perhaps here also you can think about the layering and the age. But usually, if you have a volcano, it will be based on a material that crosses and cuts across existing materials. So this is cross-cutting relationships.